Lesson 7, combinations. So a combination is a group of objects where the order doesn't matter. So permutations, the order does matter. Combinations, the order doesn't matter. So really, when you have a combination lock on your locker, it should really be called a permutation lock because the order matters. Haha. Laugh at my joke. Okay, the SRC has 9 executive members. They're selling popcorn on Friday and they need 2 people to work and sell it. How many arrangements of executives are there? Could you use permutation notation to figure this out? So, if you think about it, we need 2 people. Let's say it's Douglas and Busta. It doesn't matter which way I list them. If I put Douglas first or Busta first, either way, 2 people are there to sell the popcorn. It doesn't matter which one comes first on this list because you just need 2 people. So this is when a combination would be important. So we have 9 factorial people. That is how many objects it matters. And we're going to want to cancel out a lot of those different combinations. So the way that we're going to cancel them out is we're going to take our number, 9, and we're going to subtract how many things we need. So we need 2 people. We're choosing 2 people from the group, so we're going to subtract by 2. And that is how we get rid of anything that's repeated. So we have 9 factorial divided by 7 factorial. And 9 factorial is the same as writing 9 times 8 times 7 factorial divided by 7 factorial. 7 and 7 cancels. So we have 9 times 8, which is 72. So that is how we would solve for this if we were using a permutation. So we want less than that. And to get less than that, because we have 2 people here that we're choosing, we're going to divide this number by 2 again. And the way that we show that with factorial notation is we divide by 2 factorial on the outside. So you're going to divide it twice. So this is actually 36 options because it doesn't matter which order it is. 2 options become 1 option. So this is the formula for combinations. So the way that we can read it is N choose R. And it can also be just written in the brackets like this with an N over the R. So always just know that the number on top is N and the number on the bottom is R. So there are 9 students being placed onto teams of 3. How many different teams are possible? So we have 9 students, so N is equal to 9. We're choosing 3 different students. So we have 9 over 3, which is 9 CR, which is 3. Which is 9 factorial divided by 3 factorial, bracket 9 minus 3 factorial. So you have 9 factorial divided by 6 factorial times 3 factorial. We can write this as 9 times 8 times 7 times 6 factorial divided by 6 factorial times 3 times 2 times 1. So those will cancel. So we're left with 9 times 8 times 7 divided by 3 times 2. If you take 9 and divide it by 3, you get 3 times 8 times 7 divided by 2. If you take 8 and divide it by 2, it turns into 4. 3 times 4 is 12, times 7 is 84 possibilities. So there are 84 teams. And of course, you can type this into your calculator. 9, second function, 6 or something on your calculator, I have no idea. 3, and it will give you the answer of 84. You do need to know how to break it down by factorials. Because you don't even need a calculator, you can do this in your head. And don't forget that combinations, the order doesn't matter. They're flaky and nobody cares what order they're in.